So now we're going to learn how to multiply rational expressions, but this is a fraction multiplied by this a fraction. You're going to multiply fractions just like you did back in elementary school and middle school. We multiply straight across. So I'm going to write a little note right here that we just multiply straight across. So that's how we multiply fractions. So this numerator is going to go and get multiplied to this numerator. So I have 8x to the third y being multiplied by 7x to the fourth y to the third all over. This denominator is going to get multiplied to that denominator. So 2xy squared is multiplied by 4y. To make simplifying the fraction easier, I'm going to rearrange the numerator. So I'm going to put it so that the numbers are next to each other and that the numbers are actually prime factorized. So 8 is technically 2 times 2 times 2 multiplied by the 7. That's already prime. We have an x to the third, x to the fourth, and then we have a y, and then we have a y to the third all over. 2 is already prime factorized. The 4 needs to be prime factorized. 2 times 2 is 4. Put all the x's next to each other, put all the y's next to each other. The reason why I prime factorized out these numbers is because I want you to get in the habit of seeing the prime factors, so when these things get a lot more complex, we're looking for prime factors all the time. So I can see if there's a 2 in the numerator and a 2 in the denominator, they make the 1, so they cancel each other out. 2 in the numerator, 2 in the denominator, they make the 1, so they cancel each other out. 2 and 2, they make the 1, they cancel each other out. None of my numbers cancel each other out anymore. So I am going to rewrite my fraction, but this time I'm actually going to figure out what these variables are. So I have 7, x to the third times x to the fourth. Remember that meant you were supposed to add their exponents, so this is x to the seventh. Y times y to the third, you're supposed to add their exponents when you're multiplying them, so that's y to the fourth, all over x. Y squared times y is y to the third, so you're supposed to add their exponents. So we went ahead and we took care of our numbers. Now we need to take care of our variables. If you remember from Algebra 1, this meant that there were 7 x's in the numerator, and this meant there was 1 x in the denominator. If I look at the numerator and the denominator, this 1 will come and cancel out with one of the x's that are up here as well. So that meant that this had 1 go away, and so did he. So this 1x is going to cancel out with one of the x's up here. So that meant I only had 6 x's left in the numerator. There were 4 y's up here, and there were 3 y's down here. These 3 y's are going to cancel out with 3 more y's that are up here. So that meant up here I only have 1 y left. So these 3 y's came and canceled out with 3 of those y's, and we only had 1 y left. Nothing was left down here in the denominator. So this is our final answer, and we're done. You don't have to write the exponent of a 1. You could just write it like this. They are the same answer. Now we need to be very careful that we remember, if we're dealing with fractions, you need to deal with the fact that the denominator cannot be undefined. So because they're being multiplied, either this thing can never be 0, so we got to figure out when it actually is, or this one can never be 0. So we need to figure out when it would actually happen. So over here, the only time that this can be 0 is if y was actually 0. Over here, either the y is the 0 or the x was the 0. These are the only times when this product would equal 0 and this product would equal 0. So this is our simplified answer after you multiplied them, but you have to remember that you are not allowed to have x be 0 and you're not allowed to have y be 0. So this entire thing is our full final answer. Because if this is true, these would have been undefined, which you can't have. So this is our final answer, but there are contingencies you have to be careful of. So we have our next problem. We have a rational fraction expression multiplied by another rational fraction expression. And remember, when we are actually multiplying fractions, we're supposed to multiply straight across. So my numerator is going to come and get multiplied to my other numerator. So here is numerator 1 getting multiplied to numerator 2. Denominator 1 is supposed to get multiplied to denominator 2. So they just make one big fraction. I'm going to rearrange the numerators so my numbers are next to each other. My x's are next to each other and my y's are next to each other. Same with the denominator. Rearrange so numbers are next to each other, x's are next to each other, and y's are next to each other. Now, it's easiest for a lot of students to see if I prime factorized all of our numbers. So 3 is already prime. 6 is 2 times 3. The x's, we're not going to prime factorize them. We just need to know what we actually have. There are 6 of them there because the 5 plus the 1 is 6. My y's, I need to know how many we actually have. There are 4 because these 2 plus those 2 gave me 4. 8 needs to be prime factorized. That's 2 times 2 times 2. 9 is 3 times 3. The x's, I actually have 4 of them because the 1 plus the 3 gave me the 4. My y's, there's 2 of them because 1 plus 1 is 2. So what cancels out? What turns to 1? Well, this 2 will cancel out with one of these 2's because 2 divided by 2 is 1. This 3 will cancel out with this 3 because 3 divided by 3 is 1. This 3 will cancel out with that 3 because 3 divided by 3 is 1. So I went ahead and did all the numbers. So what I actually have is now an x to the 6th, y to the 4th, all over 2 times 2 is 4, x to the 4th, y squared. But now I got to look at my variables. There are 4 x's down here. They're going to come up and cancel out with 4 of the x's up here. So if my x's, look at just the x's, if these 4 cancel with those 4, I only have 2 x's left in the numerator. These 2 y's are going to come up and cancel out with 2 of the y's that are up there. So if 2 of these y's disappear, I have 2 y's left. These guys canceled out with the ones that are up on top. So the 4 is the only thing left in the denominator. So this is the simplified rational expression for this problem. But remember, there are numbers that x and y cannot be. You need to look at your undefines. When will this actually be undefined? Undefined means your denominator is 0. So either this denominator is the 0 or this denominator is the 0. Both cases will give us undefines. The only way for this product to be 0 is if one of these variables is 0. Same over here. The only way for this product to be 0 is if one of these variables is 0. So x cannot be 0 and y cannot be 0 because if they are, it makes one of these fractions undefined, which we're not allowed to have. So this is our fully complete final answer. So our next problem, fraction being multiplied by another fraction. We know that if we're multiplying fractions, we're just supposed to multiply straight across. So that meant I had the numerator 1 be multiplied by numerator 2. I had denominator 1 being multiplied by denominator 2. The easiest way to see this is to rearrange so that my numbers are next to each other, my x's are next to each other, and my y's are next to each other. Same with the denominator, numbers next to each other, x's next to each other, and y's next to each other. Now, I know I'm going to need to simplify. I can't really see what to simplify yet because I need to know what they're made of. So 6 is actually a 2 times 3. 9 is a 3 times 3. These x's tell me that there are actually 7 of them there. These y's tells me there's actually 3 of them there. 3 is already prime. 2 is already prime. No other x's to combine with. If there's 3 y's here and 1 more y here, I actually had 4 y's. So we need to simplify our fraction. This 2 cancels out with this 2 because 2 divided by 2 is 1. This 3 cancels out with that 3 because 3 divided by 3 is 1. There are no other numbers to cancel out with, so 3 times 3 is what's in our numerator, and that is a 9. That's x to the 7th, y to the 3rd, all over x, y to the 4th. Now that I've done my numbers, my coefficients, I need to do my variables. So looking at just my x's, I had 1 down here and 7 up here. The 1 down here is going to cancel out with one of them up there. So if I had 7 and one of them disappeared, because he told him to, there's only 6 left. So 9x to the 6th. Now looking at my y's, there's 3 up here and 4 down here. These 3 are going to cancel out with 3 of the y's that exist down here. So this y is no longer here. 3 of these are going to disappear, which meant I had only one of them left. So this is my simplified fraction. But remember, we have to go back to the very beginning and figure out when would our denominators have been undefined. This 3xy to the third cannot be 0 because if this denominator equals 0, our fraction's undefined. You can't have that. Same with this 2y. 2y cannot be 0 because if it ends up being 0, this fraction is now undefined and we can't have that. The only way that this statement is true is if y itself was 0. This statement, either y was 0 or the x was 0. So this is a true statement, except for we cannot have the x to be 0 and we cannot have the y to be 0, because if they are, then we have a 0 in the denominator, which means we now have an undefined fraction and we can't have undefined fractions. So this entire statement is our answer.